Okay, so let us begin with the fourth unit, where we are going to talk about CPM, PERT, network calculations, and a topic called network crushing as well. Okay, now, as you know, everyone, whether it's a small enterprise or a large enterprise or company, whether it is a commercial project or a small project or a large project, all needs for completing a project, whatever we need to do to complete a project is actually divided into small activities. Okay, you cannot just start with a project directly. It has to be planned properly, right? Now, the first part, when we are doing the planning of my project, the first part is to divide the whole project into smaller activities, or you can call it as events. Okay. Now, each activity will require some time, or it will require some resources, which has to be, you can say, used to complete the particular given activity or task. Okay. Now, if I have to make use of this resources in the most optimum way and complete my task in the given time, then I need to do some proper planning. Now, the two techniques which we are learning here, that is your PERT and CPM, are actually a part of this whole system, especially when we are taking up a project to complete. So, two techniques, that is PERT, that is the full form is project review, evaluation and review technique, and CPM stands for your critical path method technique. Okay. So these are two techniques which we will be using, and it helps us for project planning, scheduling, and controlling of all, you can say, the objectives which we just highlighted, that is using of your time, money, material, and so on, to the optimum use. Okay. So if I use these two techniques, there are other techniques also which are available. Like if you remember, we were talking about Gantt chart. So if you have those who have done project management, or they had gone through this particular subject of project management, they'll find that there's another technique which is basically used before we actually start, you can say, completing or start doing a particular project. That is known as your Gantt charts. Okay. So in this particular unit, we do not have that particular technique which we are going to use. So Gantt charts are not going to be taught in this particular syllabus. Okay. Now, coming to the two techniques, the first one, that is your program evaluation and review technique. Actually, it was developed way back in the year 1950. Okay, and it was developed by US Navy's Polaris missile project. So it was a result of, you can say, the US Navy's Polaris missile project. Whereas if you look at the CPM, it was developed for planning and construction of a chemical plant by DuPont company, D-U-P-O-N-T. Okay, and it was along with another corporation, that is Remington Rand Corporation. Both together came up with this critical path method. And the basic, you can say, the reason for coming up with this particular, you can say, method was to find the critical path or the critical activities where more focus should be given, so that the overall duration of my project does not get delayed. Okay, that was the main intention of your critical path method. Now, even though these two techniques are totally independent, okay, there are some common features which are available. Now, before we actually go and see these common features, let us see the PowerPoint. I'll just go to some slides here. As in the introduction, as I told you about the PERT technique and the CPM technique, the main purpose is for project planning, scheduling, and controlling. And the main reason is to complete the interrelated activities in the given schedule and make the optimum utilization or consumption of the resources which are available to us. The commonly or the most important resources which are available is time, money, and material. There can be many more if you want to keep on adding. Okay, so these are few points related to your, you can say, project planning. Okay, as I told you, PERT and CPM, PERT was the brainchild of US Navy's Polaris missile project, and it was developed in the year 1950s, somewhere in 1950s, not the exact year. Okay, whereas critical path method was developed for planning and construction of chemical plants by DuPont Company along with Remington Rand Corporation. Okay, and both these techniques, actually, there are many common things between both of them. So let us see those common features. The first and the most common feature is that in both the cases, that is whether the PERT or the CPM, the first thing we need to do is construct a network diagram. Okay, which is the main, you can say, step of both the techniques. And it involves various activities when we draw the network diagram. It involves activities and the scheduling, or you can say the time, which is allotted for each activity that is represented in the network diagram. Whereas the network diagram can be, analyzed, and we can find, as I told you, using the CPM, the main purpose is to find the critical path. So once we draw the network diagram, we can easily figure out the critical path or the critical activities and focus more on those activities and try to complete those activities in the given schedule or the given time, so that my overall project does not get delayed. Okay. Even though both of them requires the network diagram, there are many things which are different. Okay. What are the difference between the both, you can say, the techniques? The first one, that is the PERT technique, is based on the probabilistic nature. That means the time of completing a particular activity or event is not exactly known to us. Okay, so we make use of, actually it makes use of 3 completion time estimates. Those are like optimistic time, pessimistic time, and the most likely time. So 3 time estimates are used, and using this 3 time estimate, we can decide, we can come to some value of a particular task. But remember, it is probabilistic in nature. Whereas in case of your CPM is deterministic in nature, and it make use of a single fixed time. That means exact time is known to us in this case. Okay, that's the major difference between, you can say, PERT and CPM regarding the nature of the 2 techniques. So PERT is probabilistic, whereas CPM is deterministic. The second difference is that your PERT is used for projects involving non-repetitive activities. Okay, where you can say the time duration are not certain, are uncertain, right? For example, like research and development projects or launching of a product in a new market. Okay, these can be some examples for your PERT. So if you have projects where there are non-repetitive activities, please see that you make use of PERT. Whereas CPM is used for project which has repetitive activities, where your time duration is fairly certain and known to everyone. For example, is like construction of a building. Now, the main purpose, as I told you, when CPM was actually developed, it was for planning and construction of a chemical plant. Okay, and that's the reason you can see CPM is mainly used for activities which are repetitive, and one of the activities where things are repetitive is construction of a building or any plant or something. Okay. Third one, where PERT have more emphasis on the completion of a task or the event. It prepares the network from the events and is thus an event-oriented technique. Whereas CPM is an activity-oriented technique, where you can use the activities to develop the network, and thus it is known as your activity-oriented technique. And the last one Your PERT makes use of only the time calculations in the analysis. While if you see CPM, it establishes time cost trade-offs for a project. So you'll find lots of variances and standard deviations calculations, which will be done when we do the CPM. You can say use the CPM technique or draw the network diagram and try to find out the critical path and the total duration for the given project. Now, there are some steps which are involved in both, PERT and CPM technique, which we need to follow. Let us see those. The first one is your project planning. When we say project planning, this involves identification of various activities or events to be performed, stating their interrelationship. So relating to activities is very important. Then determining the resources required, such as your time, your money, your materials, which are required. Okay, that will be a part of your project planning. The second one is, or the second step is construction of a project network diagram. We will be using some standard conventions which will be given to us. We'll see that in the next few slides, so that we can depict the activities and the events involved in this project. Okay, so when we are doing the calculations, especially in case of PERT, where we do not exactly know the time duration, we need to do the calculation using the given formulas. So there's some formula available to get the time duration, especially in case of PERT. The third step would be for the network analysis, which involves like scheduling the activities and deciding the critical path in case of CPM, okay, of the project. And then it also contains identification of the slacks and floats of both PERT and CPM. Where we talk about slacks and floats, it means we are talking about the time duration, and also the probability calculations related to the project completion can be done. So if we, whatever we did in probability distribution, so a part of probability distribution is also involved when we actually do the calculation for your project completion. Again, depending on the duration which is asked, if suppose the critical path duration is say, let us say 10 weeks, for example, and what is the probability that whether I'll be able to complete that in 9 weeks. So such types of calculations will be involved when we do the network analysis. The fourth step is your project control, where it involves the aspects such as resource analysis and allocations and adjustment of resources, or the project flow, or some activities or something, depending on the changes which is happening. If there is, suppose a project is not going as per my desired, we can say pattern or route or steps, then we can easily make use of the techniques to control the project. Might be we were supposed to not, you can say, use a particular, you can say more material or in a particular event. And we find that we are going out of the budget. We are not as per the estimation which we have made. We are not able to complete a given activity in the given time. So in such cases, your project control is very important. Okay, so project control, and remember, it's a repetitive work where we keep on visiting the diagrams or whatever you can say analysis which we have done, and you can take some corrective measures to get back the project on track. Okay, so basically this 4 steps, whether we are doing PERT or CPM, these are the 4 steps which are very important, and we need to follow each step while considering these 2 techniques. Clear? Let us go ahead and see some network components and your precedence relationships which is involved in network diagrams. First of all, in a network diagram, you'll find there are two things. One is your event and the other one is activity. Okay. Now, what is an event here? The event, or we can also call it as a node in a network diagram, it represents a milestone in a project, and it occurs at a particular point of period. That means after, if there's a completion, say from the starting event to the completion of the event, it takes say 4 days to do it. Okay, so that is your time. You can time period. That is your point of you can say point of time for that particular milestone to achieve. Okay, now they only indicates you can say accomplishment of a particular process in the you can say in the whole project, and it do not consume any resources or requires any time for themselves. For example, we have taken a few example here, like fabrication of sub-assembly completion, start of brochure printing. Okay, such types of you can say these are your events, right? In a network diagram, you'll find it is represented like this, where your node is the circles given, node 1 and node 2. The node 1 is the beginning of your event or the start of your event. Okay, and your activity is actually presented on the arrow. So you can see that arrow going, and the arrow indicates the direction in which it is moving. So the movement is always, please remember, from a lower number node to a higher number node. You can call it as the tail and the head. Your head represents the, you can see the arrow part, where the event gets completed. Okay. Now, if we have more than one activity which starts from the same event, okay, it can happen. There are multiple, you can say, activities starting from the first node itself. Okay. Node here, I want to say event. So either I'll be using the word node or event, it will be interchangeable. So when I say node, I would like to refer to events, please remember. Okay. So there can be multiple, you can say, activities that might start from a particular node. Okay. This concept is known as your burst event. For that, I'll just show you the diagram here. Just 1 minute. Okay. The first diagram which I'm showing you, this one, where from one node there are two, activities beginning. It is referred as burst event. Okay. There can also be a case where, there are multiple activities which are terminating in a particular node, one node, where the diagram here, you can see it is known as your merge event. Whereas we can have a combination of your burst event and your merge event, which will have multiple, you can say, activities merging in one node and also bursting from that same node. Okay, so you can have some, you can say, nodes or relationship like this, especially based on your activities. Okay. The second is when we are mentioning the activities on the arc, there are actually two ways of drawing your network diagram. One is arc based and the other one is node based, where your activity is actually shown on the, that means inside the circle. Okay. And the second one is where we are presenting the activity on the arc. Your arc is nothing but your, you can see this arrow which we have shown. So this one. So this one is your arc. Okay, it is referred to as an arc. So activity can be shown on this or inside the node as well. Okay, so there are some different books which are available, which will show you activities inside the node. Okay, so it is right, it is not wrong. Please remember, you can use any of the techniques while drawing the network diagram. Either you put the event in the node or, sorry, the activity in the node, or you can put it on the arc. Please remember, no activities can start from it unless all the activities terminating into it are completed. Okay, so until and unless, okay, the previous activities which are terminating in a particular node is completed, we do not start the next activity. Okay, so this some rule which you have to remember when we actually do the calculation for your completion of the project, especially based on your critical path. Now, what are activities? Now, these are the basic operations which are performed, such as I told you, fabrication of sub-assembly, printing of information brochure, these, etc. Now, in a network diagram, these are represented by arrows, which are also called as arcs. And the head of the arrow indicates the direction of the progress of the project. Okay, it is always, if I'm referring to you, I'm facing you, it will be from the left hand side to your right hand side. Okay, so direction should be always this way and not the other way around. And all your previous activities should be on your left hand side, and moving forward you'll be having the new activity or the activity which is, you can say, after the previous activity, like that. So when you're drawing or numbering, even numbering the nodes, giving numbers to the nodes, 1, 2, 3, 4, has to be done in a very systematic way. Now, the example which in the diagram we can show here is for printing. It takes 4 days. So you can see on the arc, I have put printing on top, and the duration, which is 4 days, I can put it down below the arrow. Okay. And we can refer to this activity as 1 dash or -2. Okay, which we can call it as printing. So this is how you can say one activity looks like, where we have 2 nodes and 1 arc. And on the arc, we mention the activity name, okay, and you can put the duration as well. In few cases, you'll find that, just next to printing in the round bracket, they might have put the number 4, okay. Even this days need not be mentioned. Right? So you can have printing in the round bracket, just put 4 there, which is more than enough to indicate that the duration taken by for printing is 4 days, right? So this is the second, you can say, component of your network diagram. Now coming to the relationship between the nodes, let us see those. Now there are 2 words which we'll be using frequently. The activity which must be completed before an activity under consideration is known as your predecessor. Okay, predecessor activity is the activity which needs to be completed before starting the next activity. Clear? And the activity which starts immediately after the completion of an activity under consideration is called a successor activity. The activity which you can say can be carried out simultaneously or concurrently will be called as concurrent activities. We will also see some activities which are dummy activities, which will be required in cases where there are nodes or there are activities which are starting from the same node, which starts from the same node and which ends also in the same node. Okay, so in such cases, we need to introduce a dummy activity which does not have any time duration and which does not play any role in the calculation of my overall project duration as well. Okay, so we will see that as well when we come to the next slide, I think, next or after some few slides. So we might require dummy activities, as I told you, if depending on different cases. And while representing the dummy activity, the arc is actually presented as a dashed arrow. Okay, you can put dotted lines and put the arrow at the end, not as a solid line or solid arrow. I'll show you an example of that. Now, these are some graphical representation and the activity relationship which is maintained. You can see that node 1, from node 1 to node 2 represents the activity A, and from 2 to 3 it represents your activity 3. Your A is known as your predecessor or your preceding activity, and your B is your successor or succeeding activity. Okay, Your activity B cannot start until your activity A is totally complete. Clear? Now, in the previous slide also, I showed you the burst node. So the node here, node number 2, is your burst node. And there are two activities which are starting once your activity A completes. Okay, so B and C will commence concurrently. So they are also known as your concurrent activities, or simultaneously, once your activity A is over. Okay. Whereas the third one, it shows two activities which are, coming and merging into your node 3. And until and unless activity A and B gets completed, okay, C cannot start. It can happen. Let us take an example where, the activity A takes only 3 days to complete, whereas activity B takes 5 days to complete. Now, in this case, where the duration for both the activities are different, C will start only once the last activity, that is activity B, completes. That means the starting point or day for C will be the 5th day or the 6th day after completing all the activity A and B is completed. Okay. So if I want to find out the starting, you can say time or day for activity C, I need to take the maximum duration between A and B in this case. Clear? And remember, A and B may not start simultaneously as well, and neither they might end simultaneously. Okay? It can happen in a different way. Here in the example I have given 1 and 2, it indicates that's the beginning of the node or beginning of the project. So it has to start immediately. But such type of, you can say, nodes can appear in middle of your network diagram as well. Now, in this example, I can say 1 and 2, that is activity A and B is starting simultaneously, but it need not be the case every time. Okay. And the fourth diagram indicates that both A and B must finish before we start C and D. Okay. So C and D might start simultaneously. Okay. Depending on, whether all the activities like activity A and B gets completed, both of them are completed. Okay. But both need not, complete at the same duration. Both can be different. Clear? There's one more diagram, just 1 minute. This one. So here we have A and B must be complete. Okay. Before C starts. If I have this like this, and here you can see E is your dotted arrow here. This is my dummy activity. Okay. Now, why do we require? I could have put the arrow from here to here directly. Okay. But the activity D does not depend on A. And that's the reason I cannot start the new activity from here and label it as D. Okay. And that's the reason, because C depends on A and B, whereas D depends only on B. We need this dummy activity here in between so that we can have from proper diagram. Clear? So there will be some cases like this where we'll check whether we really require a dummy activity or not. And if we require it, only then we are going to introduce it. Please do not keep on adding dummy activities wherever it is, if it is not necessary to add. Okay. So you need to be very careful while introducing the dummy activity. If it is not required, please do not put it. If you are putting it without requirement, marks will be deducted for that. Then let us come to the next thing where we actually require the dummy activity. Here I've given an example where 2 or more activities have the common starting point or starting event and the common terminating point or terminal point. So A, you can see this beginning from this event and going to 2, and from 1 to 2 again we have this. But this is not the way you present your network diagram. Okay. So best way is to come with a dummy activity here. You can see this one. I put a dummy activity here, the arrow, and you can give any label here. Give a name to this. And always remember, your dummy activity does not have any duration, neither it plays any role while doing the calculation for your network diagram. Clear? There can be other situation also where you can see in the previous case, which I showed you, this one, sorry, this one, where one of the activities depended on both of them, and whereas the other one depended only on the previous activity B to get completed. So in this such situation also, you require a dummy activity to be introduced. Now, let us see some rules. We have around 6 minutes left. So I'll just introduce you to some rules of drawing your network diagram. And when we come next, we'll take some examples on how to draw a network diagram. So let us see some rules. I want you all to note this down. The first rule is only one initial node and only one terminal node is required. Please remember, you cannot have multiple nodes as the initial node. Okay, so a network should have only one initial node and only one terminal node. Okay, whereas all other nodes should be tied to the network on both the sides. One more thing, you cannot have any node which are hanging. You can say, there's some event coming and terminating in it, and that is not the last, you can say, node. Only the last node, you can say, will not have any activity coming out of it. Whereas all the other nodes which are inside this, the first node, the initial node and the last node, you'll have that they are tied up to each and every one. Okay, so it has to be one activity has to be tied to the other as well. Okay, so the nodes, especially the nodes which are between the initial and the terminal node, will have one incoming activity and one outgoing activity. Clear? That's the first rule. Now, each activity in the network should be represented by one and only one arrow. Okay, no two or more activities can have the same tail and head node. Like in the previous example, same head and same tail. Here, this one, same head and same tail. This is your head and this is your tail, right? It is not possible. You cannot have this. So this is not allowed. Clear? That is the second rule. The third rule says that an activity cannot start until all its preceding activities are completed. Okay, the network should clearly depict the predecessor and the successor relationship between the activities, and it should indicate the logical progression of the activity. That is, it should move from left to the right, okay, direction. It cannot be the other way. It cannot start from the right side and move to the left side. That is one important thing. The fourth point is the arrows should be straight and should not be crossed. Okay. There can be an exception in such case if suppose by chance the network diagram becomes very complicated and there's no other option to cross two, you can say, arrows. Only in that case arrows should cross each other. Otherwise, please try to avoid crossing the arrows. Do not put crisscross arrows at all. It should be a straight line or a straight arrow, you can say. Okay. Again, if suppose you have crossed two arrows, and if we know, okay, if I know, okay, it could have been avoided, then marks will be deducted again. Clear? Next one, your each node or your event in a network is identified by a unique number. A number is given to each node here or event. The initial event or your node is numbered as 1. Okay, and the other events are assigned numbers in their progressive, you can say, logical order. So 1, 2, 3, 4, and so on. Okay, in general, it is said that the head event, if I say J, if your head event should always be numbered higher than the tail event. Okay, tail event where we do not have the arrow. Where the arrow terminates is your head event. Okay. So your head event, the node where it is terminating, should have a higher number compared to the one which is having the tail, or where the tail is coming out of that particular node. This is a rule. Okay. Now there's another way of numbering the network diagram. In few cases, you'll find that the nodes are put and then later on the numbers are given to the network diagram. Okay, especially the nodes. By following the rule, there's a name given to this rule. You can say Fulkerson numbering rule. Okay, note down this rule and it is very helpful. There are some steps. Always number the initial node as 1. Very simple rule. Second one, delete. In the say you can hide, not delete. When we say delete, you need not clear it out. You have to just imagine that it is deleted. Okay. So delete the outgoing arrows starting from this numbered node. That is the second step. And number the nodes which now do not have any incoming arrows. Got it? So if once we complete the network diagram, give the first node as 1, hide the row or the arrows which are going outside that node. Once we hide that, check which are the nodes which do not have any arrows coming towards it, and then number that first. Okay, number the nodes which now do not have any incoming arrows and number them consecutively as 2, 3, 4, and so on. Okay, and then again we have to repeat the step number 2 and 3 again till we complete all the numbering. Clear? So this is what I wanted to take today. When we come next, we'll take one example of how to draw a network diagram.